Engineering Ambassadors is proud to present Space Telescopes, Exploring an Infinite Universe.
So imagine that you're on a beach in the middle of the night and you're trying to look for a lost ring. This can be really hard without the proper tools or even a flashlight. But now consider that you're an astronomer and your beach now is the entirety of space and the universe. This can be really hard without any of those tools, like I said before. So astronomers developed their own tools to do this. These tools are telescopes. My name is Lawrence Liu. I'm a computer systems engineering, computer science dual major at Rensselaer, and I'm a senior here.
My name is Sarah Burrows, and I'm an aeronautical engineering major here, and I'm a sophomore.
And today we'll be going over with you guys the basics of telescopes. So within this presentation, we're going to cover a few things. First, we're going to be covering the beginning of telescopes. We'll then be transitioning into the principles of optics. And then finally, we'll be talking about the discoveries of the telescopes currently and going into the future. So first of all, how many of you guys have actually used a telescope before?
I have.
Yeah, so telescopes are pretty cool. And who knows what telescopes are actually able to do for us? What can they bring into picture for us?
The moon?
Yeah, the moon or anything long distance away. So telescopes do this, and with the modern ones, it's pretty cool. They can do anything from, say, looking into it and looking at the solar eclipse, allowing us to see that, or we can just look at the moon's surface as if we were there. But this wasn't always the case. So the first ones that were ever made were pretty weak. They had about 3 times power of magnification, and they were looking kind of, well, like this. Not exactly modern. But this was the very start of it all. And this particular telescope that we have here is Galileo's telescope. With this particular telescope, he was able to look at the surface of the moon and become the first astronomer, being able to document the surface of the moon in relative detail, all done by hand as well, with no modern technology. But now let's go into a little more on how those actual telescopes work. So I mentioned before magnification, but what actually is magnification? So when we look at magnification, think of it almost as if you're going to an actual eye doctor. When you go to an eye doctor, such as me, and you got told that you cannot read the last lines on here, therefore you need glasses, it can be quite annoying, but it is necessary because you need to see it. By this same principle, telescopes allow us to look at faraway objects. So if this, say, was 100 feet away, obviously no one can see it, but with a telescope, you can easily read these lines from 100 feet away. And now let's apply this to what we have right now. So when we consider the complexity of a telescope in and of itself, we can then apply this to, say, look at the moon. And while we look at the moon, it's very far away, but when we are able to use a telescope, we can see it as if it's right there, right next to us.
And now that we've talked about the history of telescopes, we are going to now delve more into how they work. Today we're going to look at 2 types of telescopes, which will be both reflective and refracting. But we are going to start with the refracting telescope. So the refractive telescope utilizes lenses to concentrate light to a certain area, which is also called a focal point. So here we have the light rays coming in from the left side of the screen, and then they hit the convex lens. And then this convex lens causes the light to bend and pass through the focal plane. And then, once it passes through the focal plane, it hits the eyepiece, which then bends the light one last time to make it straight and give a clear image to the viewer. Now when I say convex lens, I know it's a fancy term, but I really just use it to describe the shape of the lenses here, which are ovals. And now we're going to look at the next type of telescope, which is the reflecting telescope. So consider this. Based off the reflective telescope and what it's called, what tool do you think it uses? I'll give you a hint. You probably look into this every morning when you get ready for school. Lawrence?
Mirrors!
Mirrors! Alright, so the reflecting telescope utilizes 2 types of mirrors. It has the primary mirror and the secondary mirror. So similar to the last example, the light rays will come in from the left side of the screen, and then it will hit the primary mirror. And then since the primary mirror is this flat reflective surface, the light will not travel through the mirror as it does with like the refracting telescope. It'll instead bounce off and then be projected towards the secondary mirror. And then once it hits the secondary mirror, it'll then be bounced off again one last time to make the image straight for the viewer and then also for the image to be analyzed by scientific instruments. And so an example of a reflecting telescope that is very common that you've probably heard of is the Hubble Space Telescope. But in order to understand the Hubble, we also must look at what's inside. So, shocker, the Hubble Space Telescope is actually a reflecting telescope. So this will have the light path coming in from the left side of the screen again, and then it'll hit the primary mirrors. And then this primary mirror will reflect it off towards the secondary mirrors. And then this will, again, bounce the light off. Instead of it being a human eye, though, it bounces it off towards scientific instruments that are sending the data back to the scientists on Earth. And, next slide. The Hubble Space Telescope, it was an engineering challenge because what the engineers wanted to do is they wanted to design a telescope that could see further and see clearer than ever before. So in order to do this, they had to, one, increase the amount of sunlight, or I guess light in general, that was intaken by the instrument. And then two, they also had to increase the focal length to increase the magnification of the telescope. In order to increase the amount of light taken in by the telescope, they had to increase the mirror size, which is what they ended up doing on the Hubble Space Telescope. And this allowed us to see galaxies far, far away. And so, another thing that the Hubble Space Telescope has allowed us to see is the age of the universe. Back in the day, there was a lot of uncertainty about the universe, how we came up, where we came from, how the Earth was made. But the Hubble actually helped us resolve some of this because we were able to use the data from this telescope to determine that the universe is actually 13.75 billion years old. And then another thing the Hubble Space Telescope has also done is help with the discovery of exoplanets and the births of stars and galaxies. So the discovery of exoplanets outside of our solar system has allowed us to characterize how unique, vast, and diverse our universe actually is.
So currently, there's one telescope that is going to be sent up soon that will be assisting with the Hubble telescope and also be helping discover new things. This one is the James Webb Space Telescope. This particular telescope is more powerful than the Hubble and will allow scientists going into the future to analyze the universe in more detail and hopefully discover even more things that the Hubble could not see. Another thing that was done recently by the Hubble in particular was the discovery of a planet that had water vapor in its atmosphere. This in and of itself is very unique because the only other planet as far as we know is Earth that has that. So the fact that this exists brings up the idea of potentially more life out in the universe. And in regards to the people who make these amazing devices, we look at the engineers. And engineers of all disciplines are involved in this. Can you guys name us some of them that are involved in this process?
Mechanical engineering.
Mechanical engineers. Who else?
There's also aerospace engineers.
Yes. And?
Perhaps maybe computer engineering.
Of course. All these are great examples. All these people are involved from designing the lenses, the shape of the Hubble to be able to withstand the cold of space, to even the electronics and the instruments that record all this data to be used. And going into the future, these telescopes will be helping us a lot by giving us these new scientific discoveries, and by the help of these engineers, hopefully more can be learned about space. Thank you very much for listening to this presentation, and if you have any further questions, you can contact us at Engineering Bastard.